Hello students, welcome back to the session of Laws of Motion, Part 6.
So in today's class, we are going to study about 5.9 topic Common Forces in Mechanics, which is from Laws of Motion. Is it clear? So here we are going to study about some of the common forces. So before going to study about the common forces, let's recall what do you mean by force. So what is force? A force is an external cause because of which a body changes its state from rest to motion and motion to rest. Is it clear? So here is a force which is an external cause because of which a body can change its state from rest to motion and motion to rest, and even it can change its direction. So that is about the force. In this particular topic, we are going to study some of the common forces. Okay, so let's see what are the common forces. In mechanics, we encounter several kinds of forces, and they are, so in mechanics there are several kinds of forces. Let's see what they are. So here I am going to write some of the common forces which we come across. Actually, these common forces are divided into two kinds. Those are, first one is non-contact force and the next one is contact force. So here we are going to divide the common forces into two kinds. Those are non-contact force and contact force. Here under the non-contact force, the forces which comes are gravitational force, electrostatic force, and magnetic force. Okay, so gravitational force, electrostatic force and magnetic forces are non-contact force. By the name itself indicates non-contact, means the forces which is coming into play, those are not in contact. So such kind of forces are called as non-contact force. If you observe the gravitational force which plays on any object which is going opposite to the gravity, okay, if you consider the earth, this is earth, and if you throw any object from this earth, okay, let's think that you are throwing a ball and ball is traveling in this direction. So what happens when the ball is thrown vertically upwards? This gravitational force comes into play to bring that thrown ball back to the earth. Yes or not? Whenever you throw any object from the earth, that will come back to the earth because of what? Gravitational force. Is it clear? And hence when the ball is coming back, is it in contact with the ground? No. And there is no contact between the earth and this ball, but still the ball is coming because of this force. Which force is that? Gravitational force. And hence to such kind of forces, what we call it as non-contact force. Similarly, electrostatic force, as we know that the electrons are revolving around the nucleus, okay, as the electrons are revolving around the nucleus because of electrostatic force. Similarly, in case of electrostatic force also, some charges experiences the force without contact, and hence this electrostatic force also comes under the non-contact force. And as we know, magnetic force, if we place two magnets, what happens to two magnets? If we are placing two opposite poles facing each other, then what happens to these magnets? They will attract each other, right? These two magnets are coming near to each other because of a magnetic force. Or are they in contact before coming? No, right? So these forces are not in contact, but still the force is existing. To such kind of force only what we call it as non-contact force. Completely opposite to the non-contact force, contact force. By the name itself indicates contact, means the two bodies are in contact. When the two bodies are in contact, the force which comes into play, to that only what we call it as contact force. Let's see the detailed explanation. So now we are going to study about the contact force. Let's see the definition of contact force. The force which are exerted by the two bodies on each other when they are in contact. The force which comes into play when the two bodies are in contact with each other, to that only what we call it as contact force. ಅಂದರೆ ಯಾವಾಗ ಎರಡು ಆಬ್ಜೆಕ್ಟ್ಸ್ ಅಥವಾ ಎರಡು ಬಾಡೀಸು ಒಂದಕ್ಕೊಂದು ಕಾಂಟ್ಯಾಕ್ಟಲ್ಲಿ ಇರ್ತಾವಲ್ಲ, ಆವಾಗ ಯಾವುದಾದ್ರೂ ಒಂದು ಫೋರ್ಸ್ ಎಕ್ಸಿಸ್ಟ್ ಆಯಿತು ಅಂದರೆ ಆ ಫೋರ್ಸ್ಗೆ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್. ಲೆಟ್ಸ್ ಸಿ ದ ಎಕ್ಸಾಂಪಲ್. When a book is placed on a table, then the book and table are in contact. Therefore, they exert contact force. Okay, here what does it say? If you place a book, okay, if you place a book on any table, let's see here I have placed a book on this table. Here I have tried to draw the table. Okay, so here is a table, and on this table I have placed a book. Here what is happening? The surface of the textbook is in contact with the surface of the table, and as those two objects are in contact, there is a force exerted, and to that kind of force only what we call it as contact force. You will get a clear idea by seeing many of the examples of contact force. This is an example. Let's see some other examples of contact forces. In contact force, there are many kinds of forces which are known as normal reaction, friction, and some other forces like spring force, tension force, and etc. So let's see those kinds of forces which are normal reaction, friction now. As I already told you, there are many kinds of contact forces. So let's start with normal reaction. Okay, so let's see what is normal reaction. The component of contact force normal to the surface in contact is called normal reaction. You have to understand clearly here the component of contact force normal to the surface. This is the important word here. Normal to the surface in contact. As it is a contact force, it will be in contact, that is for sure, but here what is it? Normal to the surface in contact is called normal reaction. By the name itself indicates, normal means perpendicular. Is it clear? So the component in which the object is perpendicular to the surface, and to that what we say it as normal reaction. You can see many examples for the normal reaction. Okay, now I will tell you a very general example using the book and a table. So let me consider here is a table. So here I have drawn a table. So let me draw a proper table. Okay, this is a table in which I am going to place a book or any other objects. Okay, so when you place any objects on the table, what happens? This object is putting certain force on this table. How is it putting? The object is putting the force in this direction, and the surface is this. So this is the table. Object is putting the force in this direction. So what is the angle created by the object to the surface? That is 90 degree, and this 90 degree only what we say it as perpendicular. To this perpendicular only what we call it as normal. Okay, you have to observe again the component of contact force normal to the surface. So this force is applying normally to the surface, and hence it offers normal reaction. As the object, as the textbook is putting the force on the table, equally the table will apply the force on the book using the gravitational force. Okay, so the force applied on the table by the book is considered as W, that is weight of the textbook, using the mass of the book into gravity. Okay, the gravity will also apply the opposite force equally as the textbook, which is W is equal to minus mg. Why is it minus mg? Because it is opposite to the gravity. Is it clear? Similarly, if you are standing on the ground, then what is there? You are having certain mass, this body is having certain mass, and also this earth is having certain gravity g. So what is your weight? Weight is equal to mg, and you are putting the force on the ground perpendicular to the surface, and hence what kind of force you are possessing? You are possessing normal reaction when you are standing on the ground. Is it clear? I hope you have understood the normal reaction. So let's go for the next contact force. So the next force is frictional force. Second contact force is frictional force, or just we can even call it as friction. So let's see what is friction. The component of contact force parallel to the surface in contact is called frictional force or friction. If you remember about the normal reaction was normal to the surface, whereas friction is parallel to the surface. Is it clear? So what happens if you consider an object? Okay, we considered perpendicular to the surface, and that was normal reaction. Now for this object, if applied force is in this direction, if the applied force is in this direction and opposing force, if it comes into play parallelly to that force only, what we call it as friction. The component of contact force parallel to the surface. So to this surface the force should be parallel, and to that force only what we call it as friction. Okay, in detail about the friction we will see in the coming class. In the syllabus mainly we have concentrated on the frictional force. Okay, in detail about the friction with all detailed explanation and its types we will study in the coming class. So now we will go for the next force, that is spring force. So what is spring force? Spring force means when a spring is compressed or extended by an external force, a restoring force is generated. This restoring force is called spring force. As by the name itself indicates, spring, which you might have seen in your daily life, especially in your pens, right? And to that spring only, whatever the force it possesses, to that force what we call it as spring force. And especially you have to understand here that this is a restoring force. When the restoring force comes into play, and to this kind of restoring force only what we call it as spring force. For example, now I will draw a spring here. So here I have drawn a spring for you, and this spring I will make a rigid support here. One rigid support na madbidteni. This spring you can even extend. ಈ ಸ್ಪ್ರಿಂಗ್ನ ಎಕ್ಸ್ಟೆಂಡ್ ಕೂಡ ಮಾಡ್ಬೋದು ಆ್ಯಂಡ್ ಕಂಪ್ರೆಸ್ ಕೂಡ ಮಾಡ್ಬೋದು, ಅಂದರೆ ಸೈಜ್ ಕೂಡ ಚಿಕ್ಕದು ಮಾಡ್ಬೋದು. ಸೊ ಐ ವಿಲ್ ಶೋ ಯು ಇನ್ ಡಿಫ್ರೆಂಟ್ ವೇ. ಸೊ ಈ ಸ್ಪ್ರಿಂಗ್ನ ನಾನು ಏನು ಮಾಡ್ತೀನಿ ಅಂದರೆ ಐ ವಿಲ್ ಅಪ್ಲೈ ದ ಫೋರ್ಸ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್. ಸೊ ಇಫ್ ಯು ಅಪ್ಲೈ ದ ಫೋರ್ಸ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್ ಅಂದರೆ ಯು ವಿಲ್ ಪುಲ್ ದಿಸ್ in this direction. So when you pull, what happens to the spring? Spring will elongated, ಅದ್ರದ್ದು ಸೈಜ್ ಏನಾಗುತ್ತೆ, ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ ಇಲ್ಲಿ ಏನಾಯಿತು, it was the actual position. So what happened when you have applied the force, it has increased the position. So ಇಲ್ಲಿ displacement ಏನಾಯಿತು, ಜಾಸ್ತಿ ಆಯಿತು. To this only what we call it as delta x, and delta x is known as what? Change in displacement ಅಥವಾ elongated displacement, or you can even just take it as x. Okay, now what I will do, similarly for this spring only, I will apply the force in this direction opposite to the previous one. So if you apply the force towards the rigid support, then what happens to the spring? Let's see here. So what happens to the spring? Spring will be compressed, right? I mean, it was its position, but what happened when you have applied the force in this direction, the size is decreased. Yes, one more thing you have to observe clearly here, whenever you elongate, okay, I mean whenever you pull the string, or compress the string after the removal of force, will the spring remain in the same position? ನೀವು ಫೋರ್ಸ್ನ ರಿಮೂವ್ ಮಾಡಿದ ಮೇಲೂ ಕೂಡ ಈ ಸ್ಪ್ರಿಂಗ್ ಏನಾದರೂ ಇದೇ ಪೊಸಿಷನಲ್ಲಿ ಇರುತ್ತಾ? ಡೆಫಿನೆಟ್ಲಿ ಇಲ್ಲ. ಏನಾಗುತ್ತೆ ಆ ಸ್ಪ್ರಿಂಗು? ದಟ್ ವಿಲ್ ಟ್ರೈಸ್ ಟು ಗೋ ಬ್ಯಾಕ್ ಟು ಇಟ್ಸ್ ಒರಿಜಿನಲ್ ಪೊಸಿಷನ್. ಈ ಪೊಸಿಷನ್ಗೆ ಹೋಗೋಕ್ಕೆ ಟ್ರೈ ಮಾಡುತ್ತೆ. ಆ್ಯಂಡ್ ವಾಟ್ ಈಸ್ ಹ್ಯಾಪ್ನಿಂಗ್ ಅಂದರೆ ಏನು? ದಿ ಸ್ಪ್ರಿಂಗ್ ಈಸ್ ರಿಟರ್ನಿಂಗ್ ಇನ್ ಟು ದ ಪ್ರೀವಿಯಸ್ ಪೊಸಿಷನ್. Yes, so to that only what we call it as restoring its original position. And to restore this, it will apply certain force. To that force only what we call it as restoring force. Is it clear? And to this restoring force only we call it as spring force. I hope you have understood the spring force. So what is spring force? When a spring is compressed or extended. Compressed means like this, extended means you have to pull the string, you have to pull the spring. So when it is extended by an external force, a restoring force is generated. A restoring force means which tries to go back to its original position, and to this restoring force only what we call it as spring. Okay, so there is a formula of spring force, that is F is equal to minus kx. Here F is a force which you have applied, and as I told you, x is the displacement. It shows that force is directly proportional to x. Force is directly proportional to displacement. More you apply the force, spring will extend more. More you apply the force to compress, spring will compress more. So more the force, more the displacement. Lesser the force, lesser the displacement. Okay, and in what direction it will be? After the removal of force, the displacement will be opposite to the direction of force. So we write it as F is directly proportional to minus x. To remove the proportionality constant, I will introduce a constant term which is k, and hence I will write here is equal to sign. So minus kx. K is the proportionality constant, and hence this is the formula of spring force. Is it clear? I hope you have understood the spring force. Again, to make you understand clearly, I will show you an animation so that you will get a clear idea.
So in this diagram you can observe clearly. Let's see the red point. Now what we will do, we will extend the spring by application of force. So what happened? It is rarefied, means the distance is increased. And now when you leave the object, when you leave the force, then what happens? It will come back to its original position. So again you extend, leave the force, then see the red mark, it will come back to its original position. This coming back to its original position only what we call it as restoring force, and that restoring force is called as spring force. Is it clear? I hope you have understood this. So now let's go for the next topic.
So now we are going to the last kind of contact force, that is tension force. So here what do you mean by tension? See the definition. The restoring force in a string is called as tension. It is just same as spring force, but here the restoring force we will consider in case of a string, like wires which are made up of any metals like iron, aluminium, gold or anything etc. Okay, so the restoring force in a string is called as a tension. So I will consider the string here. Let's consider a thin string which is having certain length L. Okay, so when you pull it in any of the direction, what happens? In the string a restoring force is developed. If you are applying the force in this direction, this string tries to go opposite to your applied force. To that force only what we call it as restoring force, and that restoring force which is developed in specially in string, that is what we say it as tension. You can observe this tension in the ropes which you are using in your daily life. For example, you will be having certain ropes, right? I have drawn like this. Ropes means it will be having many layers, or even you can consider whatever the rope material rope you are having, that layers will be there. In case if any person is pushing, if any person is pulling the rope in this direction, if any of the person is pulling the rope in this direction and the other side is fixed to one side with a rigid support, now what we will do, we will put the force in the opposite direction to the rigid support. Then what happens here, all the layers tries to move in this direction. But if you observe clearly here, in between what happens, certain layers will move in this direction. Try to do it, you will observe it, certain layers what happens, it will move in the opposite direction to the applied force. It is trying to bring the rope back to its original position, I mean to restore its position, and to that restoring force in the string is called as tension. I'll show you an animation so that you will get an idea.
So here you can observe clearly a bob which is attached to the string is applying the force in the downward direction, which is known as mg. Reaction to that, what is happening to the string is moving in the opposite direction. You can observe the arrow mark. One arrow mark is upwards and the other arrow mark is downwards. The downward arrow mark indicates that it is applying the force downwards. An external force is applied downwards, but to restore the position of a string, the force which is coming into play is called as tension, which is denoted by the symbol T. You can observe clearly. And the tension means, what do you mean by tension? The restoring force in string. So here the restoring force is opposite to the force mg. You can even observe the similar observations in many of the wires surroundings you. I hope you have understood all common forces in mechanics which I have explained in today's class. Okay? Thank you.